Welcome to CAD Tutorials, and in this video I'll be covering practice problem 4.8. Now, given this circuit, we are asked to find the Thevenin equivalent to the left of the terminals. So here are the terminals. We have terminals A and B, right? So we're asked to find the Thevenin equivalent to this side, right? So basically, just to give a recap of what the Thevenin equivalent is, you're basically condensing a given circuit into a voltage of value VTH, as well as a resistance of RTH. So all of this, or any circuit, can actually be transformed or condensed or simplified to this form. That is all that we have to do. So let me just quickly erase this. Then we're going to do this for this particular problem. Okay. So let's start with RTH. So to find RTH, what we have to do is, or what we have to remember is, we have to remove all the independent sources. There aren't any dependent sources here. There are two cases for finding RTH. So the first case is when you only have independent sources, and the second case is when you have a dependent source in the circuit. So in the circuit, there are no dependent sources, only independent sources, right? So what we're basically going to do to find RTH, we're just gonna, since this is case one, we're just gonna remove the independent sources which we have in the circuit and continue. So doing that, a voltage source becomes a short circuit, which is basically a line. And this current source here becomes an open circuit, which is basically the same as omitting this or taking it out. So taking that out, this is what we'll have, just the rest of the circuit. And we finally have our terminals, right? So we are now interested in RTH to the left of these terminals. So this is the load, and we are specifically asked to find the Thevenin equivalent to the left of these terminals. So here are the terminals. So we're interested in that part. We forget about this, which is a load, right? So looking at this circuit, what you'll notice is these two in series. So 6 plus 6, right? The Thevenin equivalent, or RTH, is equal to 6 plus 6. And then after adding these two, you'll see that the result of 12, right? This is a node and this is another node. And these two resistors share two nodes, which means they're actually in parallel. So the result of 6 plus 6, which is 12, is actually in parallel with the 4 ohms. So this is your RTH. So calculating that, this is 12. So 12 RTH is therefore equals to 12 multiplied by 4 divided by 12 plus 4. And then at the top you have 48, at the bottom you have 16, which will give you a value of 3 ohms. And that is your RTH. Moving on to find VTH. Now VTH is the open circuit voltage at the given terminals, or the open circuit voltage at the point which you're asked to find VTH at. So if you look at this circuit, VTH would be here. So as you can see from the terminals are over here. And this VTH actually shares two nodes with this 4 ohm resistor, which means VTH is actually the voltage which is at that node and which is across that resistor. So you can use any method which you find simple enough. Just a few mentions of those methods. You can use Nodal Analysis. Just name this node V, and then find V. After finding V, you can obviously find VTH, right? Then also what you can do is to, let's see, what you can do is also use super mesh analysis, right? You have a current source in between two meshes. You can use super mesh analysis. What else? What else can you do? So this is what I'm going to do. I'm not going to use those two. I find this method simpler. I'm going to use source transformation. So solving this using source transformation, this is what I'm going to do. Source transformation says if you have a voltage source in series with a resistor, you can actually transform that using Ohm's law into a current source of value V divided by R, right? So this is what I'm going to do. We have a voltage of value 12, right, in series with that. So taking into consideration that the plus corresponds to the direction of the arrow of the independent source, or the source which results from that, this is what we're going to have. So V of V is 12 and our resistor is 6. So 12 divided by 6 is 2 amperes. So that is the value of our new current source which we form, and it's going to be now in parallel with this same resistor, right? Then we have 2A, which is just given in the problem. That's just from the original problem itself. And this is the point where we have VTH. Now you see that I actually omitted this side of the circuit just so we'd actually focus on this node. There isn't any current flowing in or out of that point or this point. So you can actually omit those. Those are just terminals. You can just put a voltage source across and then measure voltage or whatever, right? So this is the circuit. This is essentially the circuit. But now here's a trick. You have current sources which are in parallel with each other, and as you know, if you have current sources which are parallel with each other, you can actually add them. Now these are pointing in the same direction, so we'll also have a result in that same direction of 2 plus 2, which is 4 amperes. And this is our new circuit that we have. This is our new circuit, right? And now from this point, you can basically choose what you want to do to actually find this VTH. There are actually quite a few methods which you can use from this particular point, right? But let's do source transformation once more. So we have a current source which is in parallel with the voltage source. To define the voltage, you're actually going to multiply the current by the resistor value. So 4 multiplied by 6 is 24. So that is going to be the value of that. Now again, taking into consideration that the arrow points up, so our positive terminal will be at the top. That's just a rule which you can use to remember how to draw this. So you're going to have 6 ohms, and then the 6 ohms, which is this one again. And then finally, you're going to have your 4 ohms. Now at this point, you can basically use mesh analysis or just simple voltage division. So adding these two, 6 and 6, are actually in series. So this will result in 12. And then now doing voltage division to find VTH. As we said, VTH is the voltage which is across the 4 ohm resistor. So doing voltage division, since these two are in series, we do voltage division. So 24, which is the source, multiplied by 4 divided by 4 plus 12, right? And the answer to that is 6 volts. And that is how you solve this particular problem.